Hello everyone, welcome back to Tales of Chemistry. In today's video, let's learn what are alkenes, how can we name alkenes, and what are some of the properties of alkenes. So to begin with, point number one is alkenes are hydrocarbons. So what is the meaning of hydrocarbon? They are compounds which contain only atoms of carbon and hydrogen. They have the general molecular formula CnH2n. Now, in the previous video on alkanes, I told you the general molecular formula for alkane is CnH2n plus 2. For alkene, it is CnH2n. So if you compare, you can understand that there are two hydrogen atoms less in the case of alkenes. Because of this shortage of hydrogen atoms, there is a carbon to carbon double bond is present. Okay, there is carbon to carbon double bond present in an alkene. The presence of double bond makes alkene an unsaturated hydrocarbon. Alkenes are unsaturated hydrocarbons. Alkanes, we already studied, they are saturated hydrocarbons. Alkenes are unsaturated. What is the reason to call them unsaturated? The presence of carbon to carbon double bond. Then, moving on, because of this unsaturation, they are more reactive. They are more reactive than alkanes. Alkanes, we understood that alkanes do not undergo any addition reaction. They generally undergo substitution reaction. Substitution meaning one hydrogen can be taken away and then replace it with some other atom. But addition meaning you are adding something to the already existing compound, meaning you are adding something more. Whatever is the number of carbon, whatever is the number of hydrogen, that's going to remain. Plus, you are adding something more to the compound. That is an addition reaction. Okay, so alkenes undergo addition reactions. Alkenes undergo addition reaction. Okay, so let's take some of the examples. The first example that I want to take with this general molecular formula is the first compound in the homologous series. The first compound in the homologous series has two carbons in it. Reason, you need the presence of C double bond C. So with just one carbon, we cannot establish a double bond, right? So the first compound itself is C2H4. How do we name this? There are two carbons, so the root word is eth. And the homologous series is alkene. Last three letter ENE of alkene is taken. So the IUPAC name of this compound is ETHENE, that is ethene. Now, the trivial name or common name of this compound. Trivial name or common name for ethene is ETHYLENE, ethylene. IUPAC name is ethene and the trivial name is ethylene. Okay, now General molecular formula we understood, presence of C double bond C. They are unsaturated, they are more reactive than alkane because they are able to undergo addition reactions. So let's see what kind of addition reaction, what are the examples for addition reactions of ethene. Before that, the structural formula. Structural formula of ethene, the branched structural formula, write the two carbons, connect the two carbons by means of a double bond. Then each carbon is tetravalent. Each carbon is tetravalent. So two bonds are formed here and two more bonds need to be formed on the first carbon. Similarly, on the second carbon, two bonds are already formed. Two more bonds need to be formed. So those are represented like this. Now, fill it up or satisfy all the valencies by hydrogen. This is the branched structural formula and the condensed structural formula. First carbon has two hydrogens, CH2. There is a double bond and another carbon which also has two hydrogens. So this is CH2 double bond CH2. CH2 double bond CH2, that is ethene's condensed structural formula. Now, let's see some examples for addition reactions. The first example under addition reaction that we need to discuss is hydrogenation. This hydrogenation is addition of hydrogen, adding hydrogen in presence of a catalyst. In presence of a catalyst. Because of the usage of catalyst, hydrogenation is also called catalytic hydrogenation. This hydrogenation is called catalytic hydrogenation. So let's take ethene, CH2 double bond CH2. Add hydrogen in presence of the catalyst. The catalyst taken here can be nickel at 300 degrees Celsius of temperature. So you need to heat nickel, then pass mixture of ethene and hydrogen over heated nickel. Hydrogen gets added across the double bond. As a result, double bond gets converted to single bond. See, I have already told you that the reason for the double bond was shortage in the number of hydrogen atoms. You are supplying that hydrogens now, right? So when you supply those two hydrogens, double bond will become a single bond. Already there are two hydrogens on each of the carbon. Plus, you are adding two more hydrogens, of which one hydrogen will go to the first carbon, second hydrogen goes to the second carbon. So this is nothing but CH3 single bond CH3. So what have you done here? You have converted ethene to ethane. You have converted ethene to ethane. The question can be asked the same way, as in, how can you convert ethene to ethane? Or it can be asked as, what do you get when ethene is subjected to hydrogenation or ethene undergoes catalytic hydrogenation? What do you get? Answer, ethane. And the equation also is to be studied. Moving on with some more examples for addition reactions, you can add halogen, which is termed as halogenation. You can add chlorine, bromine, or iodine. Suppose you are adding chlorine. Process is called chlorination. Take ethene, CH2 double bond CH2, treat it with chlorine in presence of carbon tetrachloride. Here, carbon tetrachloride, you cannot call it a catalyst. It is a solvent or medium for the reaction. In fact, you are passing the gases ethene and chlorine through carbon tetrachloride. Function of carbon tetrachloride is it is a medium for the reaction. It's an inert solvent which acts as a medium for the reaction. Again, as I told, you are adding chlorine, two atoms of chlorine across the double bond. First step is the double bond gets converted to single. You already have two hydrogens on each carbon. You're not disturbing them. Without disturbing them, you are adding one chlorine to the first carbon, one chlorine to the second carbon. Therefore, you get CH2Cl single bond CH2Cl. This is named as 1, 2. This is the first carbon. This is the second carbon. So first position, there is a chlorine. Second position, also there is a chlorine. 1, 2 dichloro ETHANE because of the single bond. This is ETHENE. So what did we do here? We converted ethene to 1,2-dichloroethane. What can we expect here? What question can we expect here? What do you get when ethene is subjected to, chlorination? Or else, how can you convert ethene to 1, 2 dichloroethane? Okay, equation is to be studied. Moving on. Under halogenation, the second possibility is adding bromine, which is called bromination. Now, CH2 double bond CH2 is treated with bromine in presence of carbon tetrachloride. Okay, now here even carbon tetrachloride is acting as an inert solvent. Same thing like the previous case. One bromine to the first carbon, one bromine to the second. Double bond gets converted to the single bond. So CH2, single bond CH2, Br on the first carbon, Br on the second carbon. 1, 2 dibromoethane. Now, here, possibilities here is to ask a question, how can you differentiate between ethane and ethene? Reason is, this above reaction act as a test for unsaturation. This is a test for unsaturation, meaning you can distinguish between a saturated and an unsaturated compound using bromine in carbon tetrachloride. Okay. Again, bromine has a peculiar color. Bromine has a reddish brown color. Once it combines with an unsaturated compound, the reddish brown color of bromine disappears. Why is it disappearing? Because after reaction, bromine is not existing as bromine. Fine. It is existing in the form of a Bromide, it has combined with the two carbons present here. So free bromine is not present or not existing. It undergoes a reaction. Fine. Because of which the above reaction is called a test for unsaturation. This is a test for unsaturation. Okay, now, so in minimum words here, bromine has, or bromine in CCl4 has a reddish brown color. This color fades away. The color fades away when bromine reacts with any unsaturated compound. Now, the next reaction or, addition reaction that we need to study is iodination reaction. Now, in iodination, you are adding I2, iodine molecule, across the double bond. CH2 double bond CH2 plus I2 in presence of carbon tetrachloride. You get CH2 single bond CH2, one iodine on the first and one iodine on the second carbon, and this is 1,2 diiodoethane. So these are some examples for addition reactions. Hope you have understood what are addition reactions. Now let's continue with the nomenclature, naming of the remaining alkenes as per syllabus. Let's begin with C3H6. 3 carbons are there. I've represented them. Put a double bond between any two carbons. So I have selected 1 and 2. I put the double bond. The rest of the carbons are connected by single bonds. On the first carbon, since 2 bonds are already formed, I need to represent 2 more bonds which are satisfied by hydrogen. The middle carbon, 1, 2, 3 bonds are already formed. So I need to add only 1 hydrogen on it. The last carbon, only 1 bond is already formed. So it has to form 3 more bonds. This is the structural formula, branched structural formula. How do I write the condensed formula? CH2, the first carbon has 2 hydrogens. Double bond. CH, single bond, CH3. This is the condensed structural formula. How do I name this? 3 carbons. So proper double bond between 1 and 2 carbon. Ene, propene. Okay, now, next member onwards, you will have to number the position of the double bond. Third member of any homologous series, other than alkane, you need to indicate the presence of the double bond or triple bond or whatever. So, next example, C4H8. Now, I can write the 4 carbons like this. Any one position, I need to put a double bond. So I'm choosing this position here. The rest are connected by single bonds. First carbon, Since already a double bond is existing, I need to write two more hydrogens. Second carbon, three bonds are formed, so I'll represent only one hydrogen. Third position, two hydrogens. Last position, only one bond is formed. So, three more hydrogens are represented. Now, how do I write the condensed formula? CH2, double bond CH, CH2, single bond CH3. Before we name this, let me tell you one more possibility. I'm writing the four carbons like this. And here, what did I tell you? I need to connect any two carbons, any two consecutive carbons by a double bond. Now, suppose I'm selecting these two carbons. Then the single bonds are here. Hydrogen. I should be writing three hydrogens here because of the presence of single bond. Here, I need to write only one hydrogen, here one hydrogen, and here again three hydrogens. Okay, CH3, single bond CH, double bond CH, CH3. Quickly count the number of hydrogens. 3 plus 3, 6, 7, 8. The other one also 2 plus 1, 3 plus 2, 5 plus 3, 8. Both of them have the same molecular formula, but I got two different structures. Compounds having same formula but different structure. These are examples for isomers. Regarding isomers, we will learn in detail little later. Now let's see the names of these two compounds. The first one has four carbons, so bute. Second one also has four carbons, so that again is bute. There is a double bond, so this has to be called butene. Here also there is a double bond, butene, but two compounds cannot have the same name, though both of them have just four carbons and one unsaturation, one double bond. The names cannot be the same. So, how do we differentiate between them? To differentiate between them, we will start numbering the carbons and identify the position of the double bond. When I number them, I need to give the smallest possible number, lowest possible number to the carbon which carries the double bond. So I will have to number this from here. 1, 2, 3, 4. And the double bond is between carbon 1 and 2. Out of these two numbers, 1 and 2, again I will be picking the smallest number, that is 1. So this is but1ene, or you can also write 1-butene. The second example, number it in such a way that the double bond gets the lowest position, but fortunately here you move from left to right or right to left. Your double bond is between carbon 2 and 3. Therefore, again, the smallest number is to be picked, but2ene or 2-butene. Okay, but2ene or 2-butene. Next example is C5H10. 5 carbons, 1, 2, 3, 4, 5. Let me connect the first and the second by a double bond like this. Or else, I can also do this. Connect the second and the third by the double bond. Okay. Then when I fill up hydrogen, I don't think you need any explanation now. 2 hydrogens, 2 hydrogens, and the last position, 3 hydrogens. Similarly, 3 here, 1, 1, 2, and 3. Now, what is the difference? Both have 5 carbons, so both are pent. Both have a double bond, so again both are ene. But in the first case, the double bond is between carbon 1 and 2. Second case, the double bond is between carbon 2 and 3. Therefore, the first one is pent 1-ene and the second one is pent 2-ene. Or else you call this 1-pentene and 2-pentene. All right. So that's all in this video. Stay tuned for more videos. Thank you.